Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 8, Notes 5. So we're going to be talking about area of composite figures. So what a composite figure is, it's kind of like a weird shaped figure like we have here on number 1. Now for number 1, there's no set formula we can use to figure out exactly what the area of that is. So what we do, because we can't just say, here's the formula, is we split it up into shapes that we could calculate out the formula of. So what I do first is I draw a line down here, and now I've made a rectangle, and then I drew a line here. So what I did is I looked for shapes I know. Well, I know how to calculate out a triangle. I know how to calculate out a rectangle. And now we're just going to kind of figure out the measurements that we know. Okay? So, first of all, if this segment here is 8 inches, that means that this segment here is also 8 inches. Okay, then if this whole thing has to add to 15, if this part is 8, then in order for it to be 15, this part right here has to be 7. Likewise, that makes this part here 7. Then if this part right here is 5 inches, then this part right here is also 5 inches. Now, this entire thing needs to add up to 12. So if this part is 5, this part has to be 7 for us to add up to 5. Or to 12, I'm sorry. So let's go ahead, and what I want to do now is I want to calculate out the area of each of these. So to calculate out the area of a rectangle, so for this first rectangle, we're going to do base times height. So all we have to do to get that rectangle, that first rectangle, is to do 8 times 12. And that's going to give you 96. So the area of that little, or that rectangle right there is 96. Now I'm going to get the area of this other rectangle, this one right here. Again, I'm going to do base, which is 7, times height, which is 5. And base times height, 7 times 5, is going to give me 35 for the area of that second rectangle there. Last but not least, let's take a look at this last triangle. So remember that a triangle is 1/2 base times height. Well, here we have a right angle. So this 7 is my base, and this is my height. So I have 1/2 times 7 times 7. So 1/2 times 7 times 7. And that's going to give me 24.5. So that area of that triangle is 24.5. So now for me to get the entirety of the composite figure, I need to add all those values. So 96 plus 35 plus 24.5. That's how I'm going to get each of those pieces. And then when you've done that, you calculate that out, you end up getting 155.5 inches squared. Okay, remember that it's always inches, and you take it and you square it whenever we're talking about an area. So that's for the entirety of that figure. So that's your final answer for number 1. Let's take a look at number 2. Now we want to find the area of the shaded region. Okay, so in order for us to do that, we're going to have to figure out how much each of these are going, or we want to basically figure out this height. Okay, so this right here is 20 feet. Okay, so the length of this side is 20 feet plus 25 feet plus 25 feet. So I get that that side length is 70. Then I want to figure out how much this side's going to be. Well, this is 25. And then it's also going to be 25 on this side. So then I have 25 feet here, I have 25 feet here, and then this is 100 feet. So we add 25 plus 100 plus 25, and that's going to give us 150 feet going across this way. So now we want to get the area of the shaded region, which is the big rectangle minus the small rectangle. So the area of the big rectangle is going to be base times height. So we're going to take 70 times 150. So 70 times 150. And then we're going to subtract the area of the smaller rectangle, which is going to be 20 feet, which is the height here, times 100 feet. So that's going to be 20 times 100. So then, when you go to multiply those out, you end up getting 10,500 minus 2,000. When you subtract those out. And when you subtract that out, you end up getting 8,500. And again, we want to write that as feet squared. Okay, we want to write that as feet squared so that we can show that it is the area. Next, let's go ahead and let's take a look at number 3. So we want to find the area of the shade region. They were nice and they already split some of it up for us. Okay, so we want to first figure out what the area of the semicircle is. So the area of the semicircle, first of all, here's my semicircle right here. So to get the area, if you remember talking about sectors on the previous note sheet, we need to use that formula of our degree measure, which of a semicircle is going to be 180. So we're going to take our degree measure divided by 360, so we have 180 divided by 360 times our radius, which is, as you can see in the circle, is 4 times pi. So you can go ahead and you can type that into your calculator, or you could simplify it out and do 180 divided by 360 times 16 pi. So when you type all of that in your calculator, you end up getting 25.13 feet squared for that one. Okay, so now when we talk about the area of the triangle, so we can't just assume that this side is 4 because it looks like it's the same length as the other one. What we actually have to do to get that side length is the Pythagorean theorem. So we have 4 squared plus, I'm going to call that height, x squared, is equal to 5.7 squared. Again, I'm at the point where I'm assuming that you guys can use the Pythagorean theorem just fine on your own. When you solve for x, you end up getting 4.06. Again, if that's not true, maybe you're struggling with the Pythagorean theorem, please come talk to me so I can help you with that. Okay, so then we get that my height is 4.06. So then what I'm going to do is I'm going to do 1/2 times my base of 4 times my height of 4.06. So I'm going to do 1/2 times 4 times 4.06. Multiply all of that out and you get 8.12, and that's going to be feet squared. So that's for the area of the triangle. Now we want to calculate out the area of the rectangle. Now the rectangle is the easiest one, right? Because the rectangle is simply base times height. So let's figure that out. So our base is going to be 4 feet. So we're going to do 4 times our height, which is 7. So the area of the rectangle is just 4 times 7, which is 28. And then we're going to put, again, feet squared. Last but not least, we want to calculate out the area of the total figure. So we're going to take and add all of our parts together. So we have 25.13 plus 8.12 plus 28. We're going to add each of those areas together. And when we do that, we end up getting 61.25. And again, our label is going to be feet squared. So we're just taking stuff that we had learned previously and putting it all together. Next, let's go ahead and let's take a look at number 4. So we want to find the area of the figure below. So first thing, area of the semicircle. Well, here's my semicircle right here. Okay, and we don't know right now what the height is. So we don't know what the radius is, but conveniently, I have a triangle. Okay, now this entire length right here is 31. From here to here is just 22, which means that this guy right here is 9. So to get the height, again, I can use that Pythagorean theorem. So h squared plus 9 squared is equal to 15 squared. So then again, I'm assuming you can solve for the Pythagorean theorem. So when you solve for h, you end up getting for your height of 12. So this right here is 12, which means the diameter of my circle is 12, so my radius is 6. So to get the area of the semicircle, again, we're going to have 180 divided by 360, because a semicircle is always 180 degrees, times my radius. Now my radius is half of my diameter, so my radius is 6 squared times pi. So I have 180 divided by 360 times 36 pi. And then I can go ahead and punch that into my calculator to see what I get. Well, when I punch that into my calculator, I end up getting 56.55 and then centimeters squared. Next, we want to calculate out the area of a trapezoid. So this is where having your note sheets comes in really handy, because you might need to backtrack to look at what that formula is. Now remember that the formula of a trapezoid, we're going to take the height, which is 12, multiplied by the sum of the bases. The sum of the bases is 22 plus 31, and then you're going to take that and divide it by 2. So I'm going to take the extra step and I'm going to add the bases. So then I get 12 times 53 divided by 2. So that's what I'm going to punch in my calculator, is 12 times 53 divided by 2, and that gives me 318 centimeters squared. So that's the area of the trapezoid. Now all I have to do is add those two together. So I'm just going to take 56.55 plus 318. And when you add the two of those together, you end up getting 374.55, and then again we're going to put that centimeters squared. So that's the area for your total figure on number 4. Next, let's take a look at number 5. So for number 5, we want to find the area of the shaded region. So the first thing we're going to do is calculate out the area of a parallelogram. Now remember, the parallelogram is just base times height. So to get the area of the parallelogram, you're just doing 9 times 14. So the area of a parallelogram is 126 feet squared. Something I might suggest to you is to have out notes 1, 2, 3, and 4 out while you're doing these composite figures, so you don't have to have all of those formulas memorized. Next, we want to find the area of a kite. Now remember, for the area of a kite, you multiply the two diagonals and you divide them by 2. Well, if you notice, 14 spans the diagonal of the kite, and 9 spans the other diagonal of the kite. So to get the area of the kite, we just have to take 9 times 14 and then divide it by 2. So when you do 9 times 14 and you divide it by 2, you end up getting 63 feet squared, which kind of makes sense. It's half as much as the parallelogram. So now to get the area of the shaded region, I'm going to take the area of the parallelogram and subtract the area of the kite. So 126 minus 63 is going to give me 63, and then feet squared. So that concludes your note video today. Go ahead and show me your note sheet when you're done. Thanks for listening.